Now we have another case, another special case, where they're called perfect squares. Now, when you look at things that you are factoring, this is another set of trinomials, you may notice that the first and last terms are what we call perfect squares, something that you can take the square root of nicely. All right, and I've written the rules down here. Take the square root of the first and last number. You want to write a set of parentheses. You use the middle term's sign in here. If the middle term sign is plus, you use plus plus. If the middle term sign is minus, you use minus minus. Then you go ahead and you have to check this by multiplying it back out. And when you write your answer, you're going to notice that these are identical. So you actually condense your answer and you write it as that quantity squared. Now, that's kind of the steps. I want to run through the nuts and bolts. Again, on this one, I'll give you more explanation in class on the why. This is just a mechanics lesson here on what you do. Okay? So I've got the first example up here. It says x squared minus 6x plus 9. So, when you look at the first term and you look at the last term, can you take the square root of both of those? The answer is yeah, you can. So since you can take the square root of both of those, what is the square root of x squared? Well, it's x. What's the square root of 9? Well, the square root of 9 is 3. Okay? And what's the middle term sign? The middle term sign is negative. So I'm going to use negatives there. Now, I've got some people out there who are saying, well, Mr. Trapp, this is a normal trinomial. All we needed to do is write the x and the x and come up with the factors of 9 that add to be negative 6. That's true. It's another way to do this one. And this one here is pretty straightforward. But I want you to see this is x minus 3 and x minus 3. And if we multiply it out just to check it, we get x squared minus 3x. I get another negative 3x, and I get a plus 9. Okay? Negative 3x and negative 3x, when we put it together, is negative 6x. So that works. This is that together. But since these are the same, when you put your answer in for your homework, you want to write x minus 3 quantity squared, because it's x minus 3, x minus 3. Anything times itself is to the second power. All right. Now for the second one, I've got 9x squared plus 24x plus 16. This is a perfect square, and this is a perfect square. So, they're perfect squares because I take the square root of them. What's the square root of 9x squared? It's 3x and 3x. And what's the square root of 16? The square root of 16 is 4. So I'm going to write a 4 and a 4. And what's the sign on my middle term? The sign on my middle term is positive, so I'm going to write pluses. Again, when you get these, you look at them. Now, I didn't say this earlier because I look at this one and it just pops out. You always try common factoring first. Is there any common factors on the first one? No. Is there any common factors on the second one? No. Always do the common factoring first, and then do this. So now I got 3x plus 4, 3x plus 4. I'm going to go ahead and multiply it out and check it just to make sure that it all works. So I get 9x to the second plus 12x plus another 12x plus 16. Combine my middle terms. 12x plus 12x is 24x. 9x squared plus 16, helps if you actually write what you say. And that works, doesn't it? Now don't forget, when you write your answer, it's 3x plus 4 squared. You got to put that little 2 up there. If you put it in as 3x plus 4 and 3x plus 4, your homework's going to mark it wrong. The last one, this is ugly. Now let's look, is there anything in common? I could divide a 5 out of the 25 and a 5 out of the 80. I can't pull a 5 out of the 64. We could run through all the possibilities. None of these have anything in common. So, and this here, and that's the nice part about this special case, is you look at these numbers, you think, oh, they're huge, it's going to take me forever to figure it out. No, it's not. Because, hey, that's a perfect square, that's a perfect square. Again, a lot of these factoring problems are a bit contrived, so you start to look for little things that pop out, and the fact that you can take the square root of both of them, I hope, starts to jump off the paper at you. Okay, 25x squared, that's 5x and 5x. 64y squared, that's 8y and 8y. This has got a plus sign here, so I'm going to write a plus and a plus. Now, in the interest of time, yes, we could multiply this out to check it. It will give me the middle term. Now, sometimes students will say to me, all right, I'm sick and tired of multiplying these out. Now, on this special case, if you take a look and you see that it's 80 here, the quick way to do it, just to check yourself, is to take your terms, 5 and 8, because you got 5 and 8 and 5 and 8, right? What's 5 times 8? 5 times 8 is 40. And then, since you've got a pair of them, if you think about your middle terms, you're going to have 2 of them. 40 times 2 is 80. So, and that will work for every single one. So if we look up above, 3 times 4 is 12. 12 times 2 is 24. So that's a quick way if you don't feel like multiplying it out. If that doesn't make sense and you're a little worried, hey, just multiply it out. There's nothing wrong with that. Anyway, this is the special case with perfect squares. Make sure you write your answer with the quantity to the second power. And in this one, you got to remember to use the sign of your middle term. So again, this was mechanics. I'll give you more on why it works in class if you're curious. Good luck.